Hi, hello everyone. मेरा प्यारा warriors in the classroom कैसे हैं सब? First, I have to start the session by asking a very simple sorry. I know that the classes were supposed to happen at 8 o'clock, but most of you might be knowing there was a group session going on. Many of you were there actually. Right, so obviously again I shifted my class to 8:15, 3 minutes again late. I'm really sorry because of all these things. Okay, I hope you can understand and thank you so much for waiting. And anyway, I know that my warriors are super and warriors are always here to learn with this chapter of gravitation, isn't it? Jaldi se jaldi bol de, are you all excited to learn this gravitation with me? Huh? Are you all excited to understand the topic of acceleration due to gravity in today's classroom? Huh? Jaldi se jaldi fatafat give me an amazing thumbs up in the chat box and do let me know that everyone is super excited and everyone is ready to learn this particular session. Jaldi Miara, good evening Sugamana. Yes Miara, obviously we're going to start right now. Good evening Palak, Preeti, Technical Game, Harsh, Devika. Hi to everyone in the classroom. Sab badhiya? Sab badhiya everyone? Okay. Thank you so much. So whoever is seeing me for the very first time, this is your Ameer Bhaiya, physics educator at Unacademy, and I hope you can see a bit of introduction about myself. ठीक है? Yes, hi Vansh, hi Palak, hi Shreya, Devega, hi to everyone in the classroom. This is the schedule for this particular week. You can see gravitation. Today we'll be dealing with acceleration due to gravity. Right, tomorrow, which is same time gravitational field and potential will be doing, and on 11th of October is our next class. Right, then also we'll be continuing with gravitational potential and energy. This is the schedule for this particular week, let's say. You know that amazing educators are already on board with Unacademy class 11th and 12th. So don't forget to come and join this Telegram channel where you will be getting updates of all the live classes happen. And I totally know that you don't want to miss any of the live classes which is being done by amazing educators from Unacademy, right? Then don't you think this is the best time to start learning with Unacademy? And if you want to start learning with Unacademy for free, here you have the Unacademy scholarship test, which is going to happen on 10th of October at 1 p.m. So do come and write. If you are going to get a very amazing score, you can be a part of Unacademy completely for free. So make use of it. Then I'll talk about this subscription platform for the next 2 minutes. Then we'll start with our classes. Don't worry, students. Okay. Now, why we say that, or why all educators of Unacademy say to be a part of Unacademy subscription, though everything is available for free in YouTube. It's very simple because in the platform, we educators will be teaching you with a proper schedule targeting board exam, JEE examination, and the NEET examination. And whenever we teach you any topic, we'll make sure that all the topics are in a proper order, and will also make sure that you are able to learn everything in a much easier way. So if everything is going into your head in much simpler way, what happens? Yes, finally whatever exam you are going to write, you'll be able to crack all those examination in a much simpler way, right? Isn't it? Yes, well, cool. Then top educators of the country are already there with Unacademy platform. So if you start learning with top educators who's having a very good experience in the field of education, they'll be telling you what are the kind of exam questions you should be expecting, what is the examination pattern going to be. If you can just follow them, don't you think that you'll be ending up with a very good mark in your examination, whichever you're going to write, and ending up in the colleges which you're dreaming about? Don't you think so? I really do think so. Then study materials will be given to you, practice test and live test series will make you super duper and upar ka bhi confident and will bring out the best from every one of you. And for all these amazing features, for 12 months, it is 1,250 per month. And those who want 10% of discount, don't forget to use this code of AMB10. Okay? And regarding this iconic subscription, those who want more features than what I already have described and which I have already mentioned, it would be better idea for you all to go for iconic subscription, because in iconic subscription you will be given a personal mentor. Matlab, someone to help you related to your academic activities 24/7. Let's say making the schedule, what to study, when to study, what your strategy should be, everything this person will be there. Then live doubt solving classes will be there, weekly reports will be given to you. All these amazing features of iconic you can enjoy if you go for the 12-month subscription. It will cost you 2,333 per month. And चाहिए है ना, डिस्काउंट चाहिए ना बच्चा लोग, तो ले ले. So use this code of AMB10 and get 10% of discount. And one more reason is there for me to tell you that this is the best time for every one of you to make the subscription, because if you make the subscription right now for a 12-month subscription, you'll be getting extra 4 months free. So make use of it. Fine. And one more thing, I know that every one of you are strongly preparing for term 1 examination. So if you want the support from a great educators team, I think you should be joining for this particular crash course. So biology, Pranjay sir will be there, physics, Anurag sir, and I'll be handling chemistry, Vivek sir will be there, and math, Nikki ma'am will be there. So come and join for this crash course. This is one of the best decision you can make at this point of time. And whenever you make the subscription, I hope you might be knowing the code which you want to use, which is AMB10. ठीक है, बस. Now it's all time for our topic. आप पूरे के पूरे लोग ready है क्या? मेरा बच्चा लोग जल्दी बता. Because I know that I was a bit late, let's say for 5 minutes. Now I have to start with our acceleration due to gravity. If pura ka pura log, if you all are ready to give so much of energy for your Ameer sir, I'll be like super energetic. We'll give you super energy to the classroom and we'll give you the concepts of acceleration due to gravity, just like that, where everyone can learn. Super ready? Seems like I have used the word super so many times, right? Ready, Falak, Bhavya, Sonam, Myara, Fi, Arifa, Harsh, Shreya, Preeti. वेरी गुड, बढ़िया 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 बात है, बढ़िया बात है. देख ले. Do you remember from your 8th standard onwards or 9th standard onwards, you were told that whenever there is a body, okay, whenever there is a body close to the surface of the earth, let's say this is the earth, you have some body of mass m. Whether this body, let it be an elephant, let it be an and whatever may be the body, whatever may be the shape of the body of this particular object is, it doesn't matter. Everything will be coming down with a value of 9.8 meter per second square, and we were told that this is called as acceleration due to gravity. And most of the time for calculation simplicity हम क्या करेगा, हाँ, we'll be approximating this to 10 meter per second square. How many of you have thought, अरे ये क्यों? Why everybody, even if it's an ant or an elephant, why everything has to be accelerating with the same value? There has to be some reason for this. How many of you thought what is the reason it could be, right? And those who are having confusions like this, so many doubts like this, let's solve it together, right? Dekh le idhar, dekh le. Okay, so everyone listen to me very carefully. This is very important. Understand the concept. Rest of the things will be super simple. This is our earth, hamara mother earth, which is having a mass of m. Let's say this is the center, right? I'm having a body very close to the surface of the earth. Very close matlab the height of this particular object, okay, from the surface is very lesser than the radius of the earth. Okay, so this height from where the body is very chotu hai. Okay, those who cannot see in the board, I am marking the body of mass m here, and let's say this is the height, and again marking h is very much smaller when we compare it with the radius of the earth. Okay, now don't you want to know the acceleration, why it is 9.8 meter per second square? Okay, for you to understand that, why don't you tell me what is the force experienced by this particular mass? How much will be the force experienced by this particular mass because of the gravitational force provided by our mother earth? Bata, it is equal to, sabko pata hai, G, mass of the earth, mass of the body divided by square of the distance between the centers of the body. Okay, if we start from the center of the earth, the distance will go like this, aise. So the distance will be radius of the earth plus this h. But we already have written that the body is very close to the surface of the earth. Let's say ye height hai na, let's say this is height is equal to 100 meters. And I hope you know the radius of the earth is 6,400 kilometers. So this height is very itna chotu hota hai. So force, how can I write? G m into, should I be writing r plus h whole square? No, because even if you write r plus h, it doesn't going to be making much difference. So this is going to be G m divided by r square. This is the force it experiences. Which body? The body of mass m. ठीक है. If this is experiencing a force, won't the body be having an acceleration? Yes or no? What will be the value for acceleration? The force experienced by this body, isn't it, divided by its mass. Done. Done, done, done. Bilkul sir. Substitute for this f. G m by r square divided by m. Gmm by r square is force divided by mass. Can you see something interesting? कुछ देख सकता है क्या? हाँ सर बिल्कुल. m तो इधर कॉमन है, कट कर ले because I love to find something common and to chop it off. So m तो cancel हो गया. What is remaining? G m divided by r square. This is the acceleration. Tell me, I am replacing the small mass, okay, and I am keeping a very big mass. Let's say I am keeping an elephant here. पता नहीं how to draw an elephant. लगता है कि elephant का बेइज्जती हो गया ना. So let me write. This is an elephant. So I am replacing the small mass at the same height. I am keeping elephant. इतना बड़ा mass. ठीक है, बड़ा mass. Tell me, what is the acceleration of that bada mass of elephant? Tell me. It is equal to g, mass of the earth, divided by square of the distance or radius of the earth. So will the mass of the body be actually dependent on the acceleration with which it will be coming? बिल्कुल नहीं. Which means acceleration with which the particle comes down doesn't have any relationship with the mass of the body or shape of the body or nothing. So the acceleration with which the particle will be coming down whenever the body is dropped close to the surface of the earth is only dependent upon g, which is a constant, and it is a universal constant also. M, mass of our earth, r, radius of our earth. Start substituting. G का value 6.67 into 10 power minus 11. Mass of the earth, if my memory is strong, obviously, my memory is strong hai na? So it is 6 into 10 power 24, the whole divided by radius, 6.4 into 10 power 6 meters, those who want me to write the whole square. So start substituting and start doing the mathematics, and who can guess what the value will this be? Not approximate value, actual value. What the value will this be? Let me see how many of you are super good in mathematics. Jaldi bol de. What will be the answer for this? Jaldi karke dikha. Tell me. Who is super great in mathematics, solving this particular simple chotu sa mathematics? Arey don't go and start solving with your calculator. Dimag use kar le. बस दिमाग यूज कर ले. हाँ, 9.76, or we can say that this will be having a value of 9.8 meter per second square, and this acceleration with which the particle comes down is what we are calling it as acceleration due to gravity. It doesn't depend upon mass of the body, it doesn't depend upon the shape of the body, it only depends upon the mass of the earth and the radius of the earth when the body is very close to the surface of the earth. समझ में आ गया? And this mostly we are like 9.8 is too big to calculate, and what we usually do, we usually approximate the value of g to 10 meter per second square for easiness in calculation. Now I hope that mystery, okay, is being solved. Why all the bodies, right, is having an acceleration of 9.8 meter per second square. सबको समझ में आ गया? Everyone. Myara, Shreya, Hema, Palak, Arpan, Saurav, Harsh. और क्या सर, बिल्कुल अच्छे से समझ में आ गया. ठीक है, तो ये G का तो हो गया है ना. G का तो हो गया. Now, as I have told you, acceleration depends upon G, mass of the earth by radius of the earth. Now let me ask you, is the value for acceleration due to gravity, is it going to be 9.8 meter per second square on the surface of Mars? Is it going to be? Just answer in your own head. What did I ask you? This is our mass, okay, and its radius is radius of mass, and it is having a mass of mass, mm. Mm is mass of mass, rm is radius of mass, right? What will be the acceleration due to gravity here? Is it like 9.8 meter per second square? Bilkul nahi. Go for the basic equation for acceleration. Formula G mass of that particular planet by radius of that particular planet, the whole square, right? When we were finding out for Earth, we know that it is G, mass of the Earth divided by radius of the Earth, the whole square. When we find out the acceleration of a body, okay, which is placed very close to another planet, let's say Mars, what will be the formula? G, this masses, instead of Earth, here we have mass of the Mars divided by square of the radius of the Mars. Bas. Okay, make this go into your head. This is very important. Don't think that the value for acceleration due to gravity is 9.8 meter per second square wherever you go on this universe. No, that is a wrong concept. It totally depends upon on which planet you are talking about and where you are actually. Understood? इधर तक कोई गड़बड़ नहीं, कोई गड़बड़ नहीं, I suppose. ठीक है, अच्छे से, with a smile. If you are having a smile, then obviously it simply means you understood the concept. So we are going to proceed. Let's see, we have any questions based on this or not. देख ले. Let me see how many of you are going to give me the answer even before Ameer sir. The diameters of two planets are in the ratio of 4:1. Okay, and their densities, average density is in the ratio of 1:2. The acceleration due to gravity on the planets will be in the ratio. Arey sir, we know that okay, diameter or radius is dependent upon acceleration due to gravity. ये mean density कहाँ से आ गया? How will we include the concept of mean density in acceleration due to gravity on the different planets, and we'll be getting the answer. Okay, just think what was the equation for acceleration due to gravity, what it was. What was the equation for acceleration due to gravity? We'll be writing a general equation. Tell me. G, mass of that planet divided by radius of that planet square. Is there any method by which we can introduce density? Bilkul. Array, mass is equal to, what is mass? That is equal to density into volume. Yes or no? So G, density into volume. We usually consider all the planets are having spherical shape. So this is 4/3 pi r cube divided by r square. बस तो हो गया. देख ले, r square r cube will cancel. What remains? 4/3 pi g, 4/3 pi g rho r. So this is an equation for acceleration due to gravity in terms of density and radius. You'll be thinking, sir, why didn't you teach us this particular formula? It is not necessary that we have to go with all the formulas all the time, because you know that mass is equal to volume into density, and questions will be coming in the application level only. ठीक है? Now start substituting. Okay, the question is acceleration due to gravity on different planets will be on the ratio g1 divided by g2, which means acceleration due to gravity on the first planet to acceleration due to gravity on the second planet. That is 4/3 pi g is common, so it will be cancelled off when you take the ratio. What it remains is rho r. So g1 will be equal to rho 1 r1 and g2 will be equal to rho 2 r2. अब तो हो गया. I think everyone have already given the answer in the chat box. Rho 1 by rho 2. What is the ratio of mean densities? दे दिया इधर, है ना? 1/2 लिख लें. And what is r1 by r2? Okay, I think I don't need to explain you. The ratio of diameters and the ratio of radius will be the same. So you don't have to divide this by 2. Even if you divide this ratio by 2, the answer is going to be the same, right? 4/2 by 1/2, right? That is 2:2. Then it will again be 4:1 itself. समझ में आ गया है ना? So 1/2, that is rho 1 by rho 2, and r1 by r2, that is equal to 4/1. ये हो गया 2:1. उत्तर है हमारा पास? हाँ बिल्कुल, ऑप्शन सी है हमारा उत्तर. उत्तर तो समझ में आ गया सबको? हाँ, उत्तर तो समझ भी आ गया, सबने उत्तर भी दे दिया. म्यारा, हर्ष, सौरभ, बिल्कुल बिल्कुल बढ़िया. सर एक्सप्लेन इन हिंदी. अरे मुझे हिंदी नहीं बताया तो कैसे एक्सप्लेन करेगा, है ना? मुझे थोड़ू ही हिंदी आता है. Current electricity is not one shot. Okay, we'll be taking the normal lectures of current electricity at 10 p.m. today. अरे you're from Kashmir, it's a very beautiful place, मुझे भी पता है. Tell me, does anybody have any doubt from this particular question? नहीं तो we can proceed further. कोई नहीं है, अच्छे से सबको समझ में आ गया. Okay, yes. Obviously, I'll be explaining all the concepts in English. All the concepts will be purely in English and thoda moda, which means here and there I'll be using chotu chotu English. That's all. Done before me. बढ़िया बात है मेरा. No doubt Shreya, Preeti, मेरा Ramesh, hi, hello. ठीक है, तो जाएगा. Now, the next question. We understood that if we go to a different planet, the acceleration due to gravity is different because there we have to use mass of that planet and radius of that planet. बिल्कुल सही है. Next question. Within the Earth itself, which means if we are with the planet Earth itself, are there some reasons for having different value of acceleration due to gravity at different points? Yes, there is. Actually, there are 4 different reasons which is so much important for your board examination and also for JEE and NEET. We'll go one by one. ठीक है, देख ले. First, let me write the equation for acceleration due to gravity once again. Equation क्या था? That is equal to G mass of the earth and radius of the earth the whole square. This was equation which we have written on the basis of what? Yes, on the basis that the earth is considered to be a sphere. Is earth actually having the shape of a sphere? Bata? Bilkul nahi. The earth is having almost like a geoidal shape, ऐसे, which means almost flat on the polar regions and it is bulged out on the equatorial regions. जिसको, those who don't know, this is equatorial point and this is polar point, right? So this is actually the shape of an earth, a geoidal shape, which means on the polar region flat and it will be bulged out on the equator, which simply says if you try to find out the radius at the polar regions and when you try to compare the radius with the equatorial region, will it be the same? Obviously, just look at it. Is it same? Bilkul nahi. Which means you can see that the radius of the polar region is lesser than the radius at the equatorial regions. So, will the value of acceleration due to gravity be also different? Obviously, because G is inversely proportional to the square of the radius. Yes or no? Yes. So, wherever the radius is lesser, in the case of polar, radius is lesser. Wherever the radius is lesser, the acceleration due to gravity at the polar regions will be higher. So, G in the polar region will be super high. And what about equatorial region? Radius to zyada hai. Radius is great or higher in the case of equatorial region. If the radius is high, what happens? If the radius is larger, the value of acceleration due to gravity will be lesser in this particular case, which means here the value for acceleration due to gravity will be chota hota hai. Which means if you start moving from the polar region to equatorial region, what variation can you observe in the case of acceleration due to gravity? Jaldi bata. What variation can you observe? Yes, you can see that the acceleration moves from a higher value to a lower value. Chota ho jayega the value for acceleration when you move from the polar region to equatorial region. So this is the very first reason for the variation of acceleration due to gravity, which is the shape of the earth. जल्दी से नोट कर ले. And if you have noted this down, जल्दी बोल दे. Sir, बिल्कुल हम तो नोट किया. जल्दी जल्दी जल्दी. हो गया? Everybody noted this particular concept? It's super important, let me tell you. Noted. Very good, Palak. Amazing, amazing, amazing. So yes, and please do let me know that if you are having any doubts, if you're finding any difficulty, do let me know by writing in the chat box. ठीक है? Yes. Okay. Very good. बढ़िया 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 बात. Now let's proceed further. Okay. So we got the very first reason is shape of the earth. I hope you can see a colorful picture which can actually motivate you to note it down, है ना? Okay. अरे question भी है, देख ले. The value of G at a particular point is 9.8 meter per second square. Okay. Suppose the earth suddenly shrinks uniformly to half its present size without losing any mass. Okay. Mass is the same, but it has decreased its size. The value of G at the same point, assuming that the distance of the point from the center of the earth does not shrink, which means the distance from the center of the earth to the point wherever acceleration due to gravity has to be found hasn't changed. Mass of the body is also the same. देख ले. This was the case initially. मतलब हमारा earth था, it was the radius, and let's say actually on the surface of the earth itself we had found out the value of G. G का formula G mass of the earth divided by square of the radius. है ना? Now what is happening is this is being shrunk into exactly half the size. मतलब size तो इतना हो गया, where the center is the same, and this the point is also remaining the same. If the point and the center remain the same, won't the distance between them still be the same? Yes. And it is specifically told that without losing any mass, which means this is having the same mass. So tell me, here what will be the value for acceleration due to gravity? G. Mass of the earth is the same by, as the point is the same, the distance to the point from the center, even though if it is shrunk into half, same. So this is Gm by r square. If this Gm by r square is 9.8, ये भी 9.8. So देख ले, those who know the concept, without even doing all these things, they could have just written the value. Bas. How many of you have given the answer here? Ameer, very good. Badhiya, badhiya, badhiya. Very good. C option is correct. Yes, Shreya, badhiya. It's option C. So, shall we proceed to the very next part? Huh? Next part? Okay. Yes, Devika, Ritu, Arpan, very good. Shreya, Myara, Preeti, yes, yes, Harsh, very good. I'm so happy that whoever is here in the classroom is with a complete mindset of learning this particular concept and understanding it to its depth. Second reason for having a different value for acceleration due to gravity, or the second reason for the variation in acceleration due to gravity, the height above the surface of the earth. देख ले, if we were finding out the acceleration due to gravity exactly on its surface, right here, what was the formula? G mass of the earth divided by square of the distance to the point from the center. That is the radius of the earth itself, because we have considered the point on the surface or very close to the surface of the earth. So we had the formula of G as Gm by r square. Now let's say we are considering a point not very close to the surface of the earth. Let's say at some height from the surface, h is the height of this particular body from the surface. Is the value for acceleration Gm by r square itself? बिल्कुल नहीं. Now the value for acceleration due to gravity at this height G, at this height h, will be equal to G. Mass remain the same, but the distance of the body from the center is not r, it is r plus h. So here it will be r plus h the whole square. Okay, very, 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 very important, super important. Now those who want to make some changes to this particular equation also, you can write in that way, that small changes Gm by, you can take this r outside of this particular bracket. If r comes out, it will be coming out as r square because square term was there. So this will be r square. If I take r outside, 1 plus h by r the whole square. Yes or no? What is Gm by r square? What is Gm by r square? अरे देख ले, Gm by r square was the actual acceleration due to gravity on its surface. So G by 1 plus h by r the whole square. So G at the height h is equal to this. So this is a formula. Note it down. This is more than enough. It is not necessary that you have to learn this formula because you can actually derive this from here. This is more than enough. understanding the concept. ठीक है. Now, let's say the height is not so much small, but still, if the value of h is comparably small to the radius of the earth, matlab radius of the earth is 6,400 kilometers. Let height is equal to, let's say, 5 kilometers or 10 kilometers. Still, that 5 or 10 is lesser compared to the 6,400 kilometers, which is radius of the earth. है ना? बिल्कुल. हाँ sir, बिल्कुल. I know that you all are telling, हाँ sir, बिल्कुल. In that case, can I do some approximation? Obviously. Shall we see that approximation? If the height is almost not so much lesser, but still almost lesser compared to the radius. देख ले. G at the height is equal to G. ये G, 1 plus h by r the whole square, I am taking it to the numerator. So this is 1 plus h by r the whole raised to minus 2. कोई गड़बड़ है? Now, you want to use this concept from binomial expansion. How many of you know this? 1 plus x the whole raised to n is equal to 1 plus nx plus n into n minus 1 by 2 x square plus n into n minus 1 into n minus 2 divided by 3 factorial into x cube, which means the power of this particular x keeps on increasing, right? So similarly, if I apply this particular binomial expansion here, how will it be? G into, देख ले, 1 plus x the whole raised to n is 1, 1 plus x the whole raised to n. So 1 plus n into x, what is n here? Minus 2 into x, here is h by r, plus, then it is n into n minus 1 by 2 x square. So here it will be minus 2 into minus 2 minus 1 by 2 h by r the whole square. Here it is x square, here h by r the whole square. But you have to know that we are considering the case of h lesser than the radius. So h by r itself will be a small value क्योंकि h का value small है. Now, if you square a smaller value, matlab, let's say h by r is equal to 0.01. If you square this term, how much will it be? 0.01 square कर ले, how much? 0.0001 हो जाएगा. Which means if you square it, again it will be small. So do you need to actually count those values? Square term, cube terms? No, we'll neglect it. Right? And this will be equal to G into 1 minus 2h divided by r. Now, if I say you can use this formula to find the acceleration due to gravity at a height h, will you believe me? You shouldn't be believing, because this condition has to be satisfied. It should be lesser compared to the value for radius of the earth, let's say 1 kilometers, 10 kilometers, or let's say even to 100 kilometers you can use, because radius of the earth is 6,400 kilometers, right? Only in that case we can use this formula. But that equation which is always that can be used is this one. This is the real formula, and this can only be used when the value of h is छोटू. छोटू होता है when it is compared with the radius. समझ में आ गया सबको? G into 1 minus 2h by r. बिल्कुल बिल्कुल बढ़िया बढ़िया. सबको समझ में आ गया? Yes पलक, हर्ष, म्यारा. कोई डाउट है तो जल्दी पूछ ले, जल्दी. I'll count till 10. In the meantime पूछ ले. Perfectly clear. कोई भी डाउट नहीं. अरे बाप रे. There are two reasons for not having any doubt. One is you didn't understand anything. Second thing is you have understood completely. Okay, yellang clear, right? So I'm going to think that the reason for not having any doubt is because you understood everything. Noted also. अरे क्या चाहिए? इतना अच्छा student मिलने के लिए मैं क्या how fortunate I am. I know what you are telling, sir. आप ज़्यादा dramatic हो रहा है ना? अरे रिदु, Galileo experiment के बारे में नहीं. I'm asking about this, whether you have any doubt with the acceleration due to gravity part. Okay, I hope you noted it down. These are the two formulas, you have to note it down. One is this and the other formula is this. Done, 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 done. ठीक है. Done, done, done है तो कर ले question. Okay, yes. Radius of the earth, according to the question, it is 6,400 kilometers. According to the question, it is 6,000 kilometers. Fine. Question is the weight of the body at a height of 6000 kilometer from the surface. What do you mean by at height? H value. H value is equal to 6000 kilometers, which is equal to the radius of the earth. है या नहीं? Question is at this height, okay, what will be the value for the weight of the body? Okay. Before going to that, tell me which formula can I use for finding out the acceleration due to gravity at some height? Is it gm by r plus h the whole square or g into 1 minus 2h by r? Which formula can I use here for solving this problem? Jaldi bata. Okay. Even if you don't give me the answer in the chat box, I hope you all have given your answers in your mind. Is it g into 1 minus 2h by r? Bilkul nahi. Kyun? Because that equation can only be used when the height is very small. But here the height is equal to the radius, so we cannot use it. So which formula? Haan, bilkul. G at the height is equal to gm divided by r plus h the whole square. And everyone is like, sir, nothing is asked about acceleration due to gravity. It is about the weight. Array, how will you find the weight of a body? Weight of the body on the surface is equal to mass into acceleration due to gravity on the surface. The question is, what is the weight at the height h? That is equal to mass of the body into acceleration due to gravity at the height h. है या नहीं? Mass into what is acceleration due to gravity at the height h? Substitute कर ले. Gm by r plus h. H का value is equal to r itself. So r plus h will become r plus r the whole square. So this is m gm. R plus r is 2r. 2r the whole square is equal to 4r square. I'm writing that 4 as 1 by 4 separately. हो गया. अब बता, what is m into gm by r square? Gm by r square is acceleration due to gravity on the surface into 1 by 4. I don't think anybody needs an explanation right now, because weight of the body at the height h is equal to mg, weight of the body on the surface, into 1 by 4. 1 by 4, 1/4. You don't have to do these many steps, because you can easily understand that radius is 6000, the height is also 6000, right? Which means the denominator will become twice, and the denominator value is actually squared, right? 2 square 4. So how much will it be? 1/4. Actually these are all our mental problems. आप लोगों को ऐसे ही कर सकता है ना? बोल दो. Don't you think whatever I said is correct? Okay, you can actually do it in your memory itself. ऐसे ही कर सकता है. बिल्कुल simple है. अरे Palak, those are so much amazing words. Thank you so much, Palak. Yes, yes, Palak, Arpan, Preeti, very good. Badhiya, badhiya. Bilkul. Okay, next, don't look into this graph right now. I'll teach you, don't worry. When I said don't look into the graph, it doesn't mean that we are not going to learn that. Because for understanding that particular graph, we have to understand whether we go inside the earth, whether we go into the depth of the earth, is the acceleration due to gravity change or not? Because right now we have studied that if we go to the surface, if we go to some height, acceleration due to gravity is changing. है ना? If we go to the depth, if we go inside the earth, my question is the acceleration due to gravity going to change or not? And obviously it will be changing, because the heading is given variation in value of g due to depth of the earth. So obviously it will be changing. So what is our thing to do? To find out the equation of acceleration due to gravity at a depth d. Everyone along with me, right? Okay. So let me first draw हमारा Mother Earth, right? Okay, so we have our Mother Earth, and we already know if we take a point on the surface, the value for acceleration due to gravity g here is equal to g, mass of the earth by square of the distance to the point, which is the surface, and obviously the distance to the surface is its radius. So g m by r square. Look into this part. M, the mass of the earth. है ना? Why we have considered the entire mass of the earth while finding out the value for acceleration due to gravity at this point? Because while finding out the acceleration due to gravity at this particular point, the entire surrounding mass is there to give the acceleration due to gravity at this point. The entire mass of earth is there. My question, if I take a point inside, let's say which is at a distance of r, or from the surface at a depth of d, let's say, right? So we have a point. Now, is the acceleration due to gravity the same here? Obviously not. First reason, the distance to the point itself has changed. Is any more changes is there? Let's see. Let's see, right? With a smile, let's see. Acceleration due to gravity at a depth is equal to, start going with the basic formula, g by, what is the distance to the point where the acceleration due to gravity is being found out? It is small r square. ठीक है. Next question. Is the entire mass there to provide the acceleration due to gravity, just like it was being provided to a point on the surface? Is the entire mass there? Obviously not. Now the point is here. So here, how much of mass you can expect? I can expect a mass which is confined to this much of volume. Only the mass which is confined to this much of volume, which is having a radius of small r, will be there to provide an acceleration due to gravity. Is there any problem in understanding that? This point, entire mass is there, because it can include the entire sphere. But this point, it can only include this much of sphere. So while finding out the acceleration due to gravity at the depth, we'll only be using the mass which is contained to that much of space. So g m dash divided by r square. Okay, we cannot just write it as m dash here. We have to substitute for that. How can we do? How will we find out the mass of 5 kilogram of sugar, let's say? If we have price per kilogram, right? If we have price per kilogram, multiplying it with the mass, let's say for 5, we'll get the mass, or we'll get the price of 5 kilogram of sugar. Let's say 1 kilogram of sugar has 5 rupees. So 5 kilogram will be 5 into 5, which is 25. Similarly, how can I find out the mass confined to this much of volume? If I have mass per unit volume, right? If I have mass per unit volume, I can find out the mass which is confined to this much of volume. How? Price per kilogram, mass per unit volume. Here it is multiplied by mass. Here it will be multiplied with the volume where we have to find the mass. Mass per unit volume into volume of the body where the mass has to be found out. है ना? Substitute कर ले. Total mass of the earth is capital M. What is the total volume? 4 by 3 pi r cube, considering earth to be a complete sphere. Ye v dash, the volume of this much of sphere. How much is it? Same formula, 4 by 3 pi small r the whole cube. 4 by 3 क्या दिख रहा है? कैंसिल करने का मौका आ गया तो मौका से छक्का मार ले. So g 4 by 3 will be cancelled. M r cube divided by capital R cube. I have substituted for this m dash. Remaining क्या है? R square. हो गया? Got the answer? Yes. G m r cube by r square small r divided by capital R square into R. Any problem if I write R cube as R square into R? बिल्कुल नहीं, है ना? Because I can write gm by r square as small g, small r by capital R. This is the acceleration due to gravity at a depth. But sir, we can't see the value of d here. Those who think that you want an equation for acceleration due to gravity at a depth d in terms of d, छोटू सा भी सब्स्टिट्यूशन करना है, वो क्या है, g/r acceleration due to gravity at depth is equal to small g/r. ये small r है ना, how will you represent the small r? Total r from here to here, total r subtract the small d, right? Small r is equal to capital R minus small d. So I'm going to substitute r minus d. Okay, g, if I take r inside this, inside the bracket, r/r हो जाएगा 1 minus d/r. This is not the approximated equation. This is the actual equation for acceleration due to gravity at a depth, g into 1 minus d/r. Because there is a more chance of you to get confused. You will start thinking the acceleration due to gravity at a height h is equal to g into 1 minus 2h/r. But this equation can only be used when h is very much lesser than r. But this one, you can use it at any point of time. So g at a depth d is equal to g into 1 minus d/r. This is not an approximated equation. This is the real one. Okay, done, done, done. कोई डाउट है तो बता. Done, done, done. अच्छे से. Yes. So will you ever be forgetting this equation? वादा करो मुझसे. Will you be ever forgetting this particular equation? जल्दी बोल दे. बिल्कुल नहीं सर, बिल्कुल नहीं, बिल्कुल नहीं. डन डन डन. वेरी गुड, वेरी गुड. नो डाउट्स. आ गया समझ में अच्छे से. और क्या चाहिए, और क्या चाहिए. सो यही है. So we got 3 formulas, or we got 3 different reasons for the acceleration due to gravity, or for acceleration due to gravity to be changing. 1, shape of the earth. 2nd, the height from the surface. 3rd, for the body to be inside a depth. ठीक है? ठीक है? Okay. Now, by using all these equations, shall we draw a graph for the variation of acceleration due to gravity starting from the center to the height h? Shall we? Understood with a बड़ा smile पलक. और क्या चाहिए जिंदगी पे. Understanding physics with a smile. आपका dreams है ना. So this is like a dream come true. Enjoy कर ले, मस्ती कर ले. Okay. So yes, this is the equation for acceleration due to gravity at a depth. ठीक है. Now what we are going to do is we are going to find a graph for acceleration due to gravity and small r. What is a small r? The distance from the center of the earth. Okay, with the change of value of this small r, how the acceleration due to gravity is going to change. ये हमारा earth, this is the center. First let me give, or tell me, what is the formula for acceleration due to gravity at a depth d? Formula g into 1 minus d/r. G into r, if you cross multiply, r minus d. Total is r, ये depth है d, r minus d will be small r, that initial formula which we have written. So r minus d is small r divided by capital R, है ना. Tell me, when r is 0 मतलब the point is exactly at the center, है ना. R is 0 means it is at the center. When r is 0, what is the value for acceleration due to gravity? R is 0, वो भी 0. R is 0, वो भी 0. इधर. Now, if you start moving away from the center ऐसे toward the surface, what will be increasing? R value will be increasing. So acceleration due to gravity will be increasing with a direct proportionality to the radius. मतलब कैसे? कैसे? ऐसे it will be increasing till it reaches what? Till it reaches the surface, right? When it reaches the surface, ये small r कितना हो जाएगा? At surface, GD का formula small g, ये small r हो जाएगा capital R divided by capital R. Okay, r cancel, it is g, which means on the surface, by using the formula for acceleration due to gravity at the depth, we are getting the same value of g itself, which means the 9.8 meter per second square. Bus. From here, which means from this particular part, from the surface, if you again move, how the acceleration due to gravity is going to change? Formula at the height h, gm divided by r plus h the whole square at height h. But here we are calculating the distance to the point from the center as one single term of small r. So r plus h क्या हो जाएगा? R plus h क्या हो जाएगा? Small r. So what you can write? gm divided by small r square. है या नहीं? So how it is related? Acceleration due to gravity at a height is inversely proportional to r square as a body moves away from the surface. Graph will be ऐसे, parabola. And this is the point of small r is equal to capital R. Bas. This is how the variation of acceleration due to gravity is with respect to the distance. So concept इधर तक समझ में आ गया तो we can start doing the questions. Shall we? Jaldi. Okay, I hope you all have noted it down. Give me a thumbs up if you have noted it down and बोल दे if you have any doubts. Perfect म्यारा, श्रेया अर्पण, बिल्कुल बढ़िया. शास्ता, यस रितमा, और क्या बढ़िया, बिल्कुल बढ़िया. तो हम जा रहे हैं to do the question. Noted already Palak, Shasta, Preeti, Sonam, very good, बिल्कुल. Question, start doing it. Why are you waiting for me? जल्दी से कर ले. Assuming Earth to be a sphere of uniform mass density, how much would a body weigh halfway down the center of the Earth? Halfway down मतलब ये Earth है. This depth will be equal to half the radius. Okay, this is its center. So the depth value will be equal to r by 2. If it weighs 100 Newton on the surface, okay, the weight of the body on the surface is equal to 100 Newton. How will you write the weight of the body as? Mass of the body into acceleration due to gravity is 100 Newton. ये तो दे दिया. Question is, what is the value for weight at its depth? Weight at its depth is equal to same mass into acceleration due to gravity at the depth. ठीक है. Mass into, what is the formula for acceleration due to gravity at depth? G into 1 minus d by r. Given that it is halfway the center, मतलब depth कितना है? r by 2. d substitute as r by 2. r by 2, r cancel, ये हो गया 1 by 2. 1 minus 1 by 2, ये हो गया 1 by 2. 1 minus 1 by 2, again 1 by 2 हो गया. अरे 1 by 2 का play हो रहा है. mg कितना है? What is mg? 100. 100 by 2 कितना? 50. बता, ये बता. आ गया तो आ गया. आ गया या नहीं आ गया? जल्दी. आ गया या नहीं आ गया? Simple chotu questions, but we were able to find this as simple chotu question because we know the formula and we have learned the concept. Bas, like I always tell you, once we know the concept and the formula, and if we are using it at the right place, answer ऐसे आसानी से मिल जाएगा. आसानी से मिल गया है ना? बिस्किट 50-50 वाला आया तो आया. So yes, answer option is B, है ना? हमारा option B है, which is a 50 Newton. छोटू questions. हर्ष, ठीक है. हर्ष, अभी इंटरेस्टिंग हो गया क्लास. आप ही बोल रहा था अभी क्लास इंटरेस्टिंग नहीं लग रहा है. आ गया अभी? अंडरस्टूड? आ गया तो आ गया, समझ तो आ गया, है ना? ना 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 ना, बिल्कुल तो आ गया. Okay. One more question will we do. before moving to the next part of. At what depth below the surface of the earth? ठीक है, D is a question. Value for acceleration due to gravity. Value of acceleration due to gravity at the depth is same as the value at the height. The condition to find D, let us write it first so that we won't be having any troubles later. The value for acceleration due to gravity at the depth is same as the value of acceleration due to gravity at the height. Now specifications are given. देख ले. Height h is equal to r. Okay. Now which formula we have to use? G into 1 minus 2h by r or gm by r plus h the whole square for finding out acceleration due to gravity at height. Which formula? Yes. Gm divided by r plus h the whole square cube. Why we have to use this? Because the height is comparable, right? Which means height actually itself is equal to the radius of the earth. So we cannot use the other formula G is G into 1 minus 2h by r, which can only be used if height is छोटू होता है. ठीक है. So this part is done and try to expand the acceleration due to gravity at depth is equal to, that is G into 1 minus d by r. बस हो गया. If you know how to write till here by reading the question, done. Question तो done और कुछ नहीं करना है. So देख ले, start substituting. G into 1 minus d by r, there is nothing to substitute here. It is d which we have to find out. R plus h, h is r, so r plus r, 2r, 2r square is 4r square. So gm divided by 4r square. ये gm by r square क्या है? What is g? Mass of the earth by radius of the earth. That is this small g. So ये g और वो g cancel कर सकता है ना? ये g और वो g cancel हो गया. Remaining 1 minus d by r 1 by 4 है या नहीं? है या नहीं? बिल्कुल जल्दी बता. हाँ सर बिल्कुल. ये d by r को लेफ्ट ले ले. 1 minus 1 by 4. अरे 1 minus 1 by 4 सर मुश्किल है, कर नहीं सकता. We can't do it. 1 minus 1 by 4 is 3 by 4. What is the question asked? D. ऐसे निकल गया है ना? ऐसे निकल गया without any much trouble. So D value is equal to बस हो गया. यही था काम. Yes Myara, it's 3 by 4. Very good, very good, very good. बढ़िया. A option is correct. बिल्कुल सही है. A option है. हाँ, A option is correct. बिल्कुल सही, बिल्कुल सही. Good, good. Any doubt still here? कोई डाउट है क्या इधर तक? Any doubts? कोई डाउट है तो जल्दी पूछ ले. Because we are going for the fourth reason for the variation in acceleration due to gravity. Perfect. और कुछ भी डाउट नहीं है? अच्छे से समझ आ गया? एल्लाम क्लियर आई? क्लियर? ओके, वेरी गुड, वेरी गुड. नो डाउट्स एट ऑल. डाउट ഒന്നുമില്ല. ओके, तो बिल्कुल सही, बिल्कुल सही. तो किसी को भी डाउट नहीं है तो we'll go for the very last and the fourth reason for the variation in acceleration due to gravity, which is the rotation of the earth. अरे बाप रे, this rotation is also going to produce an variation in acceleration due to gravity. Yes. Shall we understand? देख ले. ये हमारा earth again. Okay. Let's say I am having a point here. This is the center. Radius. This is also the same radius. Tell me, what will be the acceleration due to gravity at this point be? G initial will be equal to gm divided by r square. The value for acceleration due to gravity is gm by r square because we have used the entire gravitational force for providing g. What did I write here? We have got the value for acceleration due to gravity as gm by r square, which is equal to 9.8 meter per second square on the surface, because the entire force of gravity is used for giving the acceleration due to gravity. ये तो समझ में आ गया. because ये acceleration due to gravity मतलब acceleration that is provided by the force. ठीक है. Now क्या हो रहा है? The earth is gonna rotate. अरे, I hope you all know that earth rotate on its own axis. So two classes. Let's say this is rotating with some omega value in this direction. Earth ऐसे rotate कर रहा है on its axis. Okay, the earth is rotating on its own axis ऐसे. ठीक है, with an angular velocity of omega. How many of you do remember? We have already completed. If any particle is in a circular motion, what should be there? Yes, a centripetal acceleration should be provided. So once this earth rotates, the particle will also be rotating with an same angular velocity. So if the particle also rotates, yes, it has to be given a centripetal acceleration. Now tell me, what are the jobs of Fg now? Fg has to provide two things now. One is the acceleration due to gravity and the centripetal acceleration. The same force which was only providing the acceleration due to gravity has to provide now two different acceleration. So obviously won't the value of acceleration due to gravity be decreasing here? We are not doing the derivation because it is not required. Okay, so the new value of g because of rotation is equal to g minus r radius of the earth omega square, the angular velocity with which it rotates, cos square lambda. What is lambda? Lambda is the angle made by the line drawn from the center to the point with the equator. Can you see this lambda? Ye wala. Okay, whatever is a point, if you draw a line from the center to that point, it will make an angle with the equator. Okay, we usually call it as latitudinal angle also. Okay, it is not necessary that you have to go to that extent. You just learn that this is an angle made by the point with the equator. So this is the value for acceleration due to gravity when the earth rotates. We are not doing the derivation because it is not required. ठीक है, just by heart this important. Okay, yes, clear, sub clear, अच्छे से clear, amazingly clear, कोई गड़बड़ नहीं, कोई गड़बड़ है तो, कोई डाउट है तो जल्दी से फटाफट बोल दे. And please do note down this formula. कितना बड़ा फॉर्मूला इधर बड़ा, just because I have written it in a very big size. अरे ये तो बोर्ड है इसीलिए. अरे इसमें क्या है, g minus r omega square cos square lambda. How can this equation be big? वो तो बड़ा वाला स्माइल है ना, बड़ा फॉर्मूला के लिए बड़ा वाला स्माइल, और क्या. तो ठीक है, हम जा रहे हैं क्वेश्चन करने के लिए. जल्दी से जल्दी एवरीवन टेक आउट योर नोटबुक एंड पेन, स्टार्ट डूइंग द प्रॉब्लम. कर ले, जल्दी से कर ले. द रेडियस ऑफ द अर्थ इज 6400 किलोमीटर, हमको पता है ना. इट विल बी बेटर टू बाय हार्ट द रेडियस ऑफ द अर्थ वैल्यू. ओके, ठीक है. एंड g is 10 meter per second square. In order that a body of 5 kilogram weighs 0 at the equator, the angular speed is. Weight का formula? अरे यार, weight का formula m into acceleration due to gravity. When can the weight be 0? When g is 0, right? Weight will be equal to 0 when g is equal to 0. So actually the question is, in order that a body of 5 kilogram weighs 0 at the equator, so we can replace that part as, in order a body of 5 kilogram has an acceleration due to gravity of 0, what is the value for omega at the equator is? Understood? The omega value has to be found out. कैसे? Use कर ले. What is the formula for acceleration due to gravity when the earth rotates? g minus r omega square cos square lambda is equal to 0. है या नहीं? है या? हाँ, और क्या सर? ये lambda, how many of you do remember? If a particle is here the angle it makes with the equator is lambda. Now the point itself is at the equator, इधर ही है, so lambda value कितना हो जाएगा 0, है ना, because whenever we draw a line from the center to the point it will be along the equator, क्योंकि हमारा point equator पे ही है, so lambda will be equal to 0 and cos 0 is equal to 1. So ये हो गया g minus r omega square is equal to 0. So g equal to r omega square. So omega will be equal to root of g by r. बस हो गया. Now who doesn't know to substitute the value of g and r here and get the value for omega? कोई नहीं है, है ना? Substitute कर ले, omega is equal to root of g, we can approximate, take it as 10 and ये तो 6400, don't forget to convert into meters by multiplying by 10 power 3. हो गया. 10 power 3 cancel with 1, so this will become 10 square. So start taking the square root. Omega is equal to 64 का square root 8, 2 zeros, 100 का square root 0, ये 10 and 10 power 3 is cancelled, 10 square, उसका भी root 0, मतलब 10 square is 100, ठीक है, so 100 का square root हो जाएगा 10, that's why I'm keeping on adding zeros there, कोई गड़बड़ नहीं. So omega value is equal to 1 by 800, option है ऐसा, और क्या सर? बिल्कुल है. Which option? C. तो ऑप्शन C है हमारा आंसर. C is correct. और क्या? तो कोई है इधर without understanding this? नहीं है ना? I don't think so. It is basically a direct question actually, let's say. Correct? So why theta lambda? Because the question is at the equator. Okay, so the point is at the equator and lambda is actually the angle to the point from the center with the equator. So now both of them will be aligning together. So ये हो जाएगा lambda 0. Who solved the answer before me? कौन? Devika, Miara, then Harsh, Arpan, Vansh. अरे everybody has solved before me. अरे ठीक है. Okay. I hope everybody has understood why theta is equal to 0, because here earth, this is the equator, the point is also here. So if you try to draw a line from the center to the point and find out the angle that it makes with the equator, 0 हो जाएगा, because both of them will be aligning together. ठीक है, देविका, good, बढ़िया बढ़िया. और क्या चाहिए मुझे? एक और क्वेश्चन, लास्ट क्वेश्चन फॉर द डे. मुझे 10 बजे एक और क्लास है, तो एक और क्वेश्चन करेगा, फिर तो वाइंड अप करेगा आज का सेशन. ठीक है, लास्ट क्वेश्चन, जल्दी 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 जल्दी. If earth is supposed to be, okay, let's see who's going to be doing this fast, me or you. If earth is supposed to be a sphere of radius r, okay, that if g of 30 is the value for acceleration due to gravity at a latitude matlab lambda value is 30 degree, okay, the value of g minus g of 30. Very simple. You know that the acceleration due to gravity at some latitude formula, which means the same formula which we were discussing, g minus r omega square cos square lambda, है ना? Okay. Question is what is g minus g of 30? So g minus, take it to the right hand side. अरे इतना सिंपल क्वेश्चन कौन पूछता है? हम तो वैरियस है ना? cos square lambda हो गया. Lambda 30, cos 30 root 3 by 2, स्क्वायर कर ले, root 3 by 2 स्क्वायर is 3 by 4. तो ये हो गया 3 by 4 r omega square is g minus g of 30. उत्तर कहाँ है? उत्तर इधर है. उत्तर तो इधर भी है, हमको मिल गया भी है ना? जल्दी 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 हो गया, कोई डाउट नहीं है. तो shall we end the session for today? Huh? The rest of the questions we'll be doing in tomorrow's class. And let me tell you, on this Wednesday, Okay, 2 special classes are there. Special class, one is at 5:30. At 5:30 class, we'll be discussing about moment of inertia. I hope you all know. Yeah, moment of inertia from the chapter of rotation. We'll also be discussing theorems of moment of inertia, and lot many multiple choice question will be done. Don't miss this opportunity from 5:30 to 6:30 in the Unacademy app. And at 7, when is this? Yes, this coming Wednesday. I think it is 6th of October. Okay, at 7 o'clock we have rolling motion. So we have completed the chapter of rotational motion, I know that, but many of you are having troubles with the concept and by doing the problems. So at 7, we are having a special class on rolling motion. Don't forget, jaldi se aakar fatafat right now enroll kar le. Those who don't know how to enroll for the special classes, which is completely free, go and download the Unacademy learning app, log into the app, go to the menu button, okay, once you open the app, and click on special. Then go and search for my name, under my name, or these 2 topics at this particular time, enroll kar le. They'll be asking you for an invite code. Okay, वो invite code क्या है? Just याद कर ले मुझे. AM is for Ameer, B for Basith, and that 10. Yes. Okay, तो हो गया. Yes, concept plus theorem plus pole, so much excited. So I hope you all know how much exciting this special classes are, because we have real time chats will be there. You can ask your questions in the question tab. Then quizzes will be there, polls will be there, and finally leaderboard will also be there. We can understand who has actually got so much of score. So maza aa jayega. So much excited. So I'm expecting every one of you. Abhi, okay, because I don't want you to forget. Jaldi se join kar le. ठीक है, right now. And I know that many of me was asking you, sir, when is your course on Unacademy platform is going to start? It will be starting on 11th of October. It is a crash course for term 1. You know that term 1 is getting very much close to us. So you can see Pranjay sir will be taking biology, physics me and Anurag sir will be taking chemistry, Vivek sir and Max Nikki ma'am. So don't miss this opportunity. jaldi se aa jaiye. ठीक है? And the code which you have to use is AMB10. So other you can see other batches which is getting started. Okay, and right now triple dhamaka offer is going on, as you can see, for 12 months if you are taking the subscription. Free CBSE subscription for 4 months and Creative Corner subscription for extra 4 months will also be given. And for the 10% of discount, the code is AMB10. I think I don't need to tell you what the code is. I hope you all know. वही है बस. So thank you so much. And one thing that I want to tell you everyone is, those who haven't liked the session, okay, like kar le jaldi se fatafat. So that'll be a simple way you can show some love towards Ameer sir. Okay, and do let me know that you have enjoyed the class. Simple way. छोटू सा काम ले रहे हैं आपको, ठीक है, कर सकता है ना. And one more thing that I am going to tell you is, share this class with every one of you, and whenever you come to tomorrow's class, okay, do take your friends also to the classroom. ठीक है? Okay, so yes, thank you so much everyone for being here and making the class so much awesome and amazing. So bye everyone. Myara, Saurav, Devika, Palak. Okay, Manisha, Harsh, Preeti, Devika, Sankhamitra, bye everyone, bye, 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 bye. See you tomorrow. Okay, tomorrow at 8 we'll be continuing with this class, so don't forget. And one small task, yes, don't forget to take your friends also, share it with your friends also. And yes, Unacademy, let's crack it. Bye everyone.